We're going to talk about the factor and remainder theorems today. Factor. I don't make you know the names of them, but I like a title to my notes, so. Here's what you have to think about. And I want you to really think about this with me for just a minute. When we factor things, like let's say, actually let me not think about that. Let me think about if I took something like 6 and divided it by 2, what would you get? 3. What's the remainder?
Nothing.
Nothing. The remainder is 0. So when you get a remainder of 0, tell me what you know about the numbers you worked with to start with. Both are. Guys, if you can put that cell phone away, please. That's very rude. Not just positive, what else? Give me another word. What happens when you divide something and don't get a remainder? Do you know what that's called? A factor, right? A factor is something that when you divide, you get no remainder. Okay? So 2 is a factor of 6. 3 is also a factor of 6. If I divided 6 by 2, so what that tells me is not only is 2 a factor, but when you divide by a factor, you get no remainder, you also get the other factor. I promise I'm going somewhere with this. In other words, if I divide by the factor 2, it gives me another factor of 6. Is 3 a factor? Sure. Is 2 a factor? Factor means it goes in evenly, right? Okay, so both of these are factors. Okay, what it also tells me is that I could change this to a multiplication problem. What would it look like? 6 equals 2 times 3, because when you multiply the two factors together, it gives you what you started with. Yes? So this is where the theory of factoring comes from whenever we start talking about polynomials. Now, instead of talking about a 6 and a 2 and a 3, we've talked about things when we factor like x squared plus 5x plus 6. This is a factor because both of them multiply together. That's why we call this factoring. We put it in a form to where we multiply the two things together to give us what we started. Okay? So add them up and equals the middle. Yeah, this where and we put it in the box. Okay? So what this is what we're doing is a fancy form of the 6 divided by 2 equals 3. Okay? Because I could also write this if I took x squared plus 5x plus 6 and divided it by x plus 3, what do you think I would get? I should get x plus 2, right? Huh? Because these two factors together give me this. Remember the 6 equals 2 times 3 and how we rewrote it a couple different ways? If you divide by a factor, you should get the other factor. Yes. Okay. And just to show you, I'm going to do this with synthetic quickly. 1, 5, and 6. Drop it, multiply it, add it, multiply it. I got no remainder, right? So this is 1x plus 2, which is what I got here. So that's the factor theorem kind of in a nutshell. The factor and remainder theorems is that when you get a 0 when you divide, then you've started with a factor. And when you divide by that factor, you get another factor back out. Okay, so now let's apply it to what we know. Let's say I give you a polynomial. f of x equals 3x to the third minus 4x squared minus 28x minus 16. And I tell you x plus 2 is a factor. Your directions then are to factor completely. In other words, find all the other factors. If you have a factor and you need to find the other factor, what do? Divide. That's all I'm going to do. So I'm going to put you some steps over here on the side. Well, look at what would you divide by? You can do synthetic here, correct. All of these will be able to be done synthetic. The only thing we'll use long division for now is just to know that you can divide other polynomials, but as far as this kind of stuff, it'll all be synthetic. All right, so first thing I'm going to do is divide, and I'm going to divide synthetically. Okay, I think you'll watch a couple examples of it. It's pretty easy. All right, so change the sign of this number, right? So it becomes -2. I'm going to put that outside. Now, what goes on the inside?
3, 4, 28.
Watch the signs. Okay, and make sure you have placeholders if you need them. So 3, -4, -28. Okay, drop the first. Multiply, what do you get? And add. And then that process starts all over again. Multiply and add. Same process, multiply and add. For these, your remainder must be 0. It's part of that theorem, okay? You should get a remainder of 0. If you don't, something's gone wrong. Okay? So I did get a remainder of 0. Anybody lost? I think it was on the homework, but you probably didn't know how to do it.
Yeah.
Did you know how to do it?
Yeah. You taught us how to do it.
She taught you how to do this?
Yeah. Yeah, she just did all what you're doing now, just with a box.
Yeah, she factors
No,
it
she
out
ain't
with
she
her.
got
No,
factoring.
because she factors differently than you factor. She doesn't use brackets.
All right, so now what you need to do, at least you'll have like a step sheet in your notes too. This. After you have divided, you need to write, actually, let's say interpret your answer. Interpret your answer. Which means, tell me what this is. Okay. Now, what you have to do, because the directions, remember, said factor completely. So what I want to do is I want to write it as a multiplication problem.
In the box.
And then we're going to box it. And what I mean by multiplication problem is, remember that 6 and 2 and 3 that I put in the beginning, and the 2 and the 3 I multiplied together to get 6. So you take what you divided by, which was x plus 2, and multiply it by what you got, which was 3x squared minus 10x minus 8. Now comes the part where you factor what you can.
We don't have to multiply it out.
No, we're not gonna, multiplying it out would bring you back to where you started.
So we just do it in the box, right?
So we do, put it in the box, exactly.
Alright, so I don't need to do step 3. What?
Well, whenever you write your final part, it's gonna have to have the x plus 2 in front. But yeah, you can just throw that in front if you understand. So when I do put this one in the box, these signs are gonna be mixed. And I need two things that multiply to negative 24x squared, but add to negative 10x.
What'd you get negative 24?
Remember, multiply the first, okay.
6 and 4. I lose.
Mixed signs though, one positive, one negative.
6, 4.
That gives you 2,
Or
negative 2.
negative 4 and 6.
That gives you 2.
Alright, negative 6 and negative 4.
One positive, one negative.
Alright, negative 4 and negative 6. No. 4 and negative 6. This is the same thing.
4 and negative 6 is negative 2.
Alright, so then the only thing is negative 4 and plus negative 6.
So you're telling me the only two factors of 24 are 4 and 6?
No.
No.
8.
8
That
and,
doesn't fit.
8 and 3 doesn't work.
10.
12 and 2, good job. Negative 12 and positive 2. Come on in. I told y'all whenever we did factoring it would never go away. Here it goes again. All right, greatest common factor here. 3x. How about here?
2.
2. How about here?
X.
And here?
Negative 4.
Good job. So the x plus 2 hasn't moved, it's still there, and now I have 3x plus 2.
X minus
Now it's factored completely.
4.
Does that make sense?
Yeah, we didn't do the.
You didn't do this?
I swear we did.
You did?
I swear we did.
That confusing?